welcome to Friday's edition of Cracking the Cryptic, and we're going for from the sublime to the ridiculous today. Yesterday, Zeta Maths Puzzle Buffet featured, I think, the longest rule set that we've ever featured on the channel. Today's puzzle, which is called Primal Instinct by Agent, features what must be one of the shortest rule sets on the puzzle. In fact, I'll just tell you what the rules are. Normal Sudoku rules apply, and digits in cages cannot repeat and must sum to a prime number. And then there's an explanatory sentence which says, for the avoidance of doubt, 1 is not a prime number. And that's all of the rules. Absolutely fantastic stuff. A slightly daunting grid with no given digits, and it's actually not fully covered in cages either. But we've had this one recommended to us a few times over the last days, and some of the comments have been just ridiculously good. Someone said that this is frankly the best Sudoku puzzle they have ever seen. So if you like your prime numbers, I think you might enjoy this one. Now I've got some news for you before we kick off today. Which bit of news shall I do first? I'll do the word related news. So some of you may know that Mark does Wordle in a Minute. That's a video that appears on the channel as a YouTube short normally every day. It's also on TikTok and Instagram for those of you who frequent such places. And Mark does Wordle on hard mode, which means that when you make a guess, you have to use any positive information you get from that guess in any subsequent guesses. So you can't do, any of the old tricks about guessing sequences of 5 different letters each time in order to hone in on the actual letters used. Anyway, Mark is very good at this, but you may, if you have a bit of Schadenfreude in your personality, you may want to have a look at the video that we released earlier on today, which was not a YouTube short, because indeed it is about 6 minutes long, and it features Mark getting progressively more and more baffled, and it's just such a rare thing to see that I think many of you will enjoy it. I'll try and remember to put a link on the screen. Now, for those of you who have that Schadenfreude in your personalities, you may also enjoy watching me struggle. We did a Times Crossword masterclass in inverted commas today. I solved the Times Crossword. I did solve it. That's probably not worth a spoiler, is it? I do solve it in the end. But I have to say, the last entry in particular, I have a great deal of difficulty with. So if you want to see me really quite baffled, you can watch that video. I'll try and remember to put a link to that on the screen. Now, what else can I tell you about? Let's do some birthday announcements. I'm very nearly caught up with my birthday announcements after my brief holiday last week. So JC, you have turned 54 today, I believe. I think it's today, actually. So this is not a late one. Over there in Virginia, and I know this because your wife Jennifer wrote to us, and I hope I've got the day right, JC, and I hope you have chocolate cake. Not a birthday, but Macy has just graduated with a first-class degree. Well done, Macy. And Macy enjoys Killer Sudoku, so this should be right up your street, Macy. And I know all this because your boyfriend Stephen wrote to us and wanted to let us know how proud he is of you for achieving that degree. Well, as he should be. I think this is the constructor Nordy for the next birthday. Nordy, is it your birthday today? Maybe we should have reached out for a Nordy puzzle. But anyway, Gotta Glow wrote to us and said that you'd appreciate a shout out. Next, Patricia in Shrewsbury, in a different part of England than I'm in, but not that far away. Now, Patricia is a grandmother of a 7 and nearly 9-year-old, who I think are in Germany actually. But Patricia, happy birthday, and this message is from Ines, Neil, Sakura and Lily, and I think so. Sakura, it must be your birthday soon. Happy birthday for that. Rich turns 28 today, which is indeed the 28th of the month, so a golden birthday. Hope you have chocolate cake to celebrate, Rich. And then a late birthday, Scott, on the 19th over there in Massachusetts. I think most of your family are actually near Saratoga, but your daughter Sarah wrote to us and described you as an amazing dad, and she couldn't ask for a better father. which is a rather nice thing to hear. So Scott, I hope you had a great birthday. And Sarah did in fact share with me something quite wonderful, which I'm going to share with you. This, which is her art about our monthly reward, the Planet Suite, which was our Sudoku hunt over on Patreon for last month. And look, Maverick is flying through the planets. Isn't that absolutely brilliant? So Sarah, thank you very much for sharing that with me. I'm most impressed. I love fan art when we get it. It really does. It tickles me pink. And that brings us nicely on to Patreon, where I have an apology to make. We left off some names yesterday from the Roll of Honor that we did, because the way we construct the Rolls of Honor is we search for the answer in our Gmail account. Now, unfortunately, some people left out the spaces in their answers, and therefore we missed those out yesterday. So many apologies. And what we thought we should do, because those people were also therefore left out of the prize draw, is we're going to give another prize. So we drew that out, and Chase Phillips, well done. You have won the other prize now for this month's monthly reward. Cracking the cryptic, so congratulations. We'll run another Roll of Honor. It's a much shorter Roll of Honor. It's about 30 seconds long at the end of this video. And don't forget, if you are into Sudoku hunts, and why wouldn't you be, 1st of August, it's only a few days away, and we have a brand new hunt coming up to you, collaboration between Cracking the Cryptic and Glum Hippo, about tennis no less, and that is looking in fine shape indeed. So we know you're going to like that. So if you want to get involved in that competition, do join us. Do join us before the 1st. A couple of bucks a month, and most people would tell you who are patrons that it is the best value entertainment on this planet. Certainly per hour of enjoyment you get. Anyway, that's all the messages. Let's have a look at Primal Instinct. I've done the rules. I don't have to do the rules again, do I? So let's see what Agent, who is a constructor I really, really like, has got in store for us. The way to play is to click the link under the video as usual, but now I get to play. Let's get cracking. So I'm going to have my prime number brain on today, aren't I? And probably avail myself mightily of the secret. Yes, okay, I can. I mean, I don't know if this is how you're meant to go about doing this puzzle, but I can tell you something about that digit. So maybe we should start by me telling you the secret. Now, the secret is something I only tell my very favourite people. But if you are prepared to watch a man solve a Sudoku about prime numbers by a fantastic constructor and spend your Friday night in such fashion, then you are absolutely one of my favourite people. You and I would get on mightily finely at a party. Now, the Sudoku secret is that any complete row, any complete column, and any complete box of a Sudoku contains the digits 1 to 9 once each, because of the rules of Sudoku. And if you add up those numbers, you get 45. Now, 45 is an interesting number because it's odd. Now, let's think about how this box might work. If these two cells have to add up to a prime number, there's only one even prime number, and that's 2. And you can't make a Sudoku domino add up to 2 without repeating a digit. So that's not going to work. So we know that each of these dominoes adds up to an odd number, and there are 4 such dominoes, aren't there? Now, add 4 odd numbers together, you get an even number, but 45 is an odd number, so that digit must be, you've guessed it, that's odd. In fact, this might be a parity shading puzzle. We'll mull that over. Yeah, okay, because look, can't I extend that logic here? Again, each of these cages must add to an odd number, but if that cage adds up to an odd number overall, and that is itself an odd number, those digits must add up to an even number, which means that these 8 cells add up to an even number, because 2 odd numbers, which that's odd, plus that even, we must be on an even total now, so that's also odd. So we now know these 3 digits add up to an even number. Okay, no, I might have run out of cleverness now. Oh dear, dear, dear. Oh. No. Right, I can do the same thing in row 6. Odd plus odd plus odd is odd. We need to retain that odd parity, so that is even. Now, that therefore is definitely odd, because that domino must add up to an odd number overall. Oh, I like this so far. I do like parity puzzles. Oh. Oh, sorry. No. Okay. There's single digit cages here. None of these can be a 1, because 1 is not a prime number. Oh, sorry, I forgot. One of them could be a 2. Oops. I was about to say these have to be 3, 5, and 7, but I forgot that 2 was prime and could go in a cage if that cage is a 1-cell cage. Oh. Okay. No, we can do a different. Well, it's a similar logic but different on this box overall. That's an odd number, isn't it? And that's an odd number. This cage. So at the moment we're on an even total, which means these 3 digits have to add up to an odd total, which means that they well, if one of them was even, there's only one even prime, so the other 2 would be odd, and they would add up to an even total. So 2 is not involved in these 3 cells, and therefore, because 9 is not prime, we must be looking at 3, 5, and 7. That's the only 3 single-digit primes that are not 2. That's huge, isn't it? That's going to be huge. Now, right, so 1 and 9 now have to be allocated. One of those digits has to go into this cage, and one of them has to go into this cage, because we need to ensure that each cage individually has an odd total, and to achieve an odd total you will need an odd number. Trust me, you can add as many even digits as you like and you won't get to an odd number. Right. Okay, so if we had a 1 here, these 2 digits would both be even. But they could be something like 2 and 4, couldn't they? That would be easy, or 4 and 8. Okay, there are options. What about with 9? If we go 9, this was a 9. 924 doesn't work. 926 does. Oh, 928 does. Oh, 689 also. Okay, alright, so this is probably not where we look next. There seem to be lots of ways we can make totals that add up to prime numbers using 1 and 9 and even numbers only. This must be not, this can't be relevant. Oh, what about that row? That, though, is a bit of a naughty digit, isn't it? That's a 1-cell cage, but we don't know its parity. It could be 2 again. So I was thinking I could get this digit, but I don't think I can until I know whether that's odd or even. Oh, what about... Well, actually, I'm actually switching tack now. I'm wondering about geometry, about this cage. This is one of these cages that we see in Killer Sudoku. We don't see it often, but it has a very understood effect to my brain, at least, which is that it causes roping. What do I mean by roping? Well, what I mean is that because... Oh, I just had another thought. But okay, well, we'll come back to that. I'm going to do roping first. I had another thought. Yes, what is roping? Well, the question is, or the effect arises because you can't repeat digits in a cage. So these 3 cells here, we can ask where they live in box 8, and they can't live there because they'd repeat in this cage. And they can't live there because they'd repeat in their row. So they must live there, which means they live there. And once you get that effect, you can then ask where those digits go in box 7. And they can't be green. Green's already appeared in box 8, so they must go up here, which means they go there by Sudoku. And we can create these lovely and strange ice cream flavours like this. Right, so now, well, now I'm no doubt we'll be able, well, no, I'm not in no doubt, but I'm sure we can do something. Possibly. Or we might have to use the other thing I noticed. Hang on. hang on. Can we deduce anything sensible from this? I know these 3 digits are definitely adding up to an odd number. Oh, sorry, I'm not spotting any. That's really weird, actually. I'm slightly surprised about that. I think I have a horrible feeling I'm missing something terribly obvious. The other thought I had, just to let you know what that is to look at those 9 cells together as a package. Because these 2 corner cages here, they see the entirety of that 7-cell cage. You can't, I mean, what do I mean by see? What I mean is, let's imagine this digit was a 5. Can that 5 appear anywhere in that cage? Well, clearly not, because it would rule 5. It would see the 5 either in its box or in its row. So these 2 digits and these 7 digits must be the 9 Sudoku digits altogether. But, yes, okay, but I know that the total of these 7 digits is odd. So in order, if this is 9 Sudoku digits, which we know add up to the secret, which is 45, then these 2 cells must add up to an even number, which means they must have the same parity. And because there is only one cell number that could be a prime that is even, we can't, if we put 2 in one of these, we can't find a second even number to put in that would be prime. Both of these are odd. Neither of them are 1, neither of them are 9, so these are 3, 5 and 7. And that's given us a 3, 5, 7 triple in column 1. That's quite beautiful, isn't it? It's really, really fascinating to me that you can actually start to deduce things from just a whole bunch of cages. Now what I'm tempted to do, well, yeah, okay. So we can ask a question like, oh, my maths was wrong. No, it's not wrong. My maths is not, no, my maths is wrong. 8. No, my maths is wrong. Oh, Bob. Oh, no, well, all right, I'm going to change it round. My maths was wrong, but I'm going to change it round so my maths becomes right again. Okay, could those 2 digits be 3 and 7? No, because if this is 3 and 7, we know what the sum of this cage is. It's 45 minus 3 minus 7, which is 35, and 35 is not prime. So this cannot be a 3-7 pair. Now, can it be a 5-7 pair? No, because 5 and 7 add up to 12, which would mean this was a 33 cage, and 33 is not prime either. So this has to be 3 and 5. It's the only thing it can be. And 3 and 5 is the number I first thought of, which I thought didn't work, but actually does, because that makes this cage add up to 37, and 37 is prime. And now, right, now I've got a 3, 5, 7 triple that's slightly different in column 1, in the sense that the 7 in this triple is definitely in this domino here. So that's not a 7, and now I've got a 3, 5 pair in column 2. And okay, so now I know there's a 3 and a 5 in here, and a 3 and a 5 in here. Three and 5 add up to 8. So I've got, right, so this needs another odd digit, doesn't it? Because we need to change the parity of this cage in order for this cage to add up to an odd number overall. You can't add 1 to it because 9 is not prime. If we add 7 to it, 15 is not prime. Yeah, so that's got to be 3, 5, 9. It's the only way we can. And now that's become a 9. This is absolutely incredible. And the wonderful thing about it is, it's so far, it's not that, it's not monstrously hard, is it? We can at least do it. And we're going to probably get a 3 in the corner. Come on, right, now what does that mean? I'm not sure yet, though. These two cells are both odd, so they add up to an even number. So this is a 1 or a 7, because it must be odd to make that cage have a prime total. Now, okay, now I'm not spotting anything at all, which is a bit embarrassing. Can I revisit row 7 now? If that's odd, yes. Yes, oh, that's so pretty. It's so pretty. Right, I know what that digit is now. I actually know exactly what it is, and that will give you a clue as to how because if we look at the parity now of this row, that's odd. Those 3 add up to odd numbers. These 4 add up to odd numbers. So these 8 cells add up to an odd total, because that's 3 odd numbers we're adding up. So that, in order to retain the parity of 45 for the row, which is odd, needs to be even. So that's got to be 2. It's the only possibility. So now this cage has got all the other even digits in it. It's got 4, 6, 8, and either 1 or 7. And 4, 6, and 8 add up to 18. And if you add 7 to 18, you get 25. And 25 is not prime, so you must add 1 to it, and you get 19, which is prime. And that gives us this digit, which is now a 7. This is just, it's beautiful. Absolutely beautiful. So now there's 2s and 7s in green. Look, 2 and 7. 2 and 7. Hang on a minute, let me think about that. Does that help us with anything at all? 7 here. Can we get this sorted out? I doubt it. Although it's not 3 and 5 here, because 3 and 5 would make this cage add up to 15, which won't work. So there is definitely a 9 in this domino, and that's not 9. Let's see if we can do any better than that. So if we do 9 and 3, we get 19, wouldn't we? Which is fine. And if we do 9 and 5, 40. No, 21 doesn't work. 9, 5, 7 doesn't work. That is 21. Yeah, so we can't put 5 in there. So 5 goes there, and we get a 3, 9 pair. And this adds up to 19, which is fine. So now, right, now look, we can do some deletions up here. Not many deletions, though. Don't know what to do now. We've got... okay, what am I meant to do now? So far as well, what I've loved is that everything, it's been very linear. So I think what I need to do here is I need to just spend a moment or two. If I can't find an obvious next step, I'm probably missing something. I'm sorry. Let me just mull this over. So I know green. Green has got 1 of 1, 4, 6, and 8. I've got to make this cage. This has got to add up to a prime number. And the corner digit. Oh, I don't know. I'm not sure how to think about this, actually. Can that be 2, 7? That would give us 21, 20. No, right. That corner digit is 2 or 7, I think. Because by Sudoku, I know there's a 2 and a 7 down here. And if that 2, 7 go here, then unless my maths is wrong, which it could be, those squares add up to 21. And that would mean these squares add up to 24, which is most certainly not prime. So I think we've got to put 2 or 7 here. But does that... I feel like there's a parity thing going on there. Or does it? No, it's going to depend on what the other digit is here, which could be either parity. Ah, okay. What would be useful in the corner? 7 would be more useful. It would at least affect these digits. Oh, bobbins, I don't know. How do we think about this better? So these are from 1, 4, 6 and 8. These are from 1, 4, 6 and 8. One, 4, 6 and 8. Oh, I'm sorry. I'm not understanding quite what I meant to look at here. Has anything improved? Has this 9 given me anything? This 5, this 7, this 2? These are from 1, 4, 6, 8. I feel it's this T pentomino that might do something. That, oh, it could never be 9. Oh, you can nearly do something in column 9. Look, that have to add up to odd, so that's even overall. Now it's odd, so these have to conserve that parity. So if that's 7, that's got to be odd, and if that's 2, that's got to be even, which is looking quite likely, isn't it? Whatever this is goes down here. Oh, I'm sorry. I've hit an absolute brick wall. It might be, one thought I've just had is maybe I have to actually really think about the options for this cage, which is a slightly terrifying thought. Is that really what I'm being asked to do? Could be. Let's put in the options there. Now, if this was 4, 6, 8, if all of these were even, what would we then be saying? 4, 6, 8. This would be 1. This would be 1, 2, 7. So we'd have an... Oh, what would we have there? We'd have 18, 23. Yeah, that doesn't work. I think we do have to have 1 in here. So there must be some there's something parity-ish going on here. I just can't see what it is. That's odd. If I don't include 1 in here, those are even. And then I can't include the 2 because that's going to give me 25, and that doesn't work. And if I include the 7, I get to an even total, which doesn't work. So I definitely need to have a 1 in there, which means I definitely need to have a 1 in here. This is not a 1 anymore. And now, if we think about the overall parity, I'm going to be able to get this digit, I think, because I've got odd plus the 1 is odd, so I'm on even now, plus 2 evens is even, but the overall cage must be odd, so that puts 7 in the corner. How strange. That is, well, that's useful for those 2 digits. Oh, look, now hang on, can't I do that parity thing I was thinking about on this column? I thought these had to be the same. Let's just double check that. That's odd. That's odd. That's even overall. Plus an even number. 5 and 7 are even. So I need an odd number here to get to 45, which is odd. There we go. That's another digit. Okay. Now, is this useful? Well, actually, the 1 is useful. Now I've got a 3-9 pair up here, so it's getting slightly better. One idea I could do... what have I got there? 13, 32. So I've got to split 32 between these, such that both cages add to prime numbers. That's probably worth thinking about. But I just want to have a think down here in a minute, for a moment. Because I really would like to know... I know I've got a 1 down here now. And a 4, 6 or an 8. How am I going to do all this disambiguation in the bottom of the grid? Oh, I tell you one thing we might be able to do. Can we get these 2 digits? It's possible. That's probably what we have to do. 13. Okay, well, 4 and 6 would give us 23. That's fine, isn't it? But 13 and 12 is 25. So we must have a 6 in here, otherwise we've got a problem. And what about if we added 14? 27 is not prime, so that doesn't work. So we do, it's 4, 6. Aha, right, that is what we were being led towards. 1, 4, 6 is what we have in blue. So we don't have an 8, so we do have an 8 here, which means we've got 2, 8 here. We've got 1, 4, 6 here. Ah, no, I want to do central pencil marking, and we can get rid of the corner pencil marking here. Put 2, 7, 8 here, and no, that doesn't. Hang on, let's just check. I don't think it's going to do much because I don't think we've got anything in the top parts of the grid that are going to be huge. No, okay. Alright, so I'm going to revert to the other thought I had, which was this column. Right, so we're splitting 32, aren't we, between these cages, and the minimum value of this is 5, which would be prime. But it wouldn't leave... Okay, that doesn't work. Because obviously that would make this 27, which is not prime. Alright, let's try 7. 25 doesn't work either for this cage, so that doesn't work. 3 and 6 doesn't work because that's 9 and that's not prime on its own. 3 and 8 is prime, that's 11. And 11 would leave 21. 21 is just not prime, so that's got to be a 9, we've suddenly discovered. This is ludicrous. Right, well 11 isn't going to work again, isn't it? Because that's going to give me 21 again, so we can take the 2 out of here. If we have 13... we have 19. Okay, this is where it's going to... No, but I can't have 6. That doesn't work, because 15 is not prime. 17, does that work with that? 15 is not prime. That's absurd. That's so absurd. So this is 13, this is 19, and we know what those digits are, which are 2, 6 and 8. Let's just double check. So that is 19. So 2, 6 and 8 here. Oh, hang on. I've used up very many. Yes, okay. So I've used up rather a lot of even digits in this box already. Oh, hang on, I've just spotted some Sudoku. I'm just going to do Sudoku. No, no, bobbins. That stopped there being a 3 in the corner. Rotten thing. Wow. Okay, hang on. There's other Sudoku we can do as well. Don't forget your Sudoku in your Sudoku puzzles, folks. It doesn't help you. 5 can go in that cage. 9 is in this cage, look, at the bottom. So 9's in this one, which means 1's in this one. 4 is in this one. I'm jumping about all over the place. I know there's some logic I can do up there, but I suddenly saw the Sudoku. So we've got 5 in there, and we've got to add on another even digit. Well, we could add on 2, couldn't we? We could add on 6, And we could add on 8. Ah, you rotten thing. Okay. All right. Okay. Well, let's go back up here, because the thing I was thinking about was that what I can't do is put 2 odd digits in this domino, because if that's 2 odd digits, they will add up to an even number, and that's not going to be prime, because we can't make these add up to 2. So there must be a 4 in there, which means that's a 4, that's a 6, which means 6 is in one of those squares. These digits are all odd. This digit is odd, obviously. And this has got one odd number with it, which could be 1, 3. It can't be 5. Okay, so no, that could still be 5. Bother. Can it be? No, it can be 7. Oh, it can be 7 or 9. Wow. Wow. Okay, that's disappointing. Wow. This is weird, isn't it? So how on earth am I meant to make progress from here? I mean, odd, odd. So we're on incorrect parity at the moment, because we're on even overall. So these have got to be of different parities. Yeah, that's it. Look at that. It's so good. This logic is so good, because now I can write in this digit. So the puzzle is really clever. It's fantastically clever, because it keeps giving you something that it just doesn't seem to exist, and yet it does. So I could see that this had to be an odd number, because I've used up my even numbers in the box. And therefore I could see I was going to get the parity of this, and I was hopeful it would give me the perfect parity, and it did, because that is a 1-cell cage that has to be even to make the row add up. So just let me go through that again. Odd, odd, even. So at the moment we're on even. We've got to get overall onto odd, but we know that's an odd number, so that's got to be even to retain the parity. And it's a 1-cell cage, so it can only be 2. This is no longer 2. There's now a 5 in this cage. We know that this is odd. I don't even think that's worth pencil marking, is it? All 3 of those are odd. I'll tell you what I'll do. I will do that. I will label them. I would normally do parity shading, but I've sort of not gone down that route in this puzzle, so I'll probably... Oh, that's odd as well. So we've only got one more odd in those digits. It's not going to be something like, you know, there's... No, I think there must be loads of odd numbers that will work up here. I was wondering whether there might... I mean, I can see 1, 3 and 5, for example, won't work as the odd numbers there, but I think that there are lots of numbers that will. Let's try... 159 doesn't work either. 179, that will work. Yeah, okay. I think there are lots. I'm not sure, but I think that there are lots. Okay. So can we do parity on this box now if we know that this is 2? We know that those 6 cells are overall even, don't we? Odd, odd, even. So we're on even, which means these 3 cells have to add up to an odd number. One of them is odd, so the other 2 have the same parity. So this is either 2 even numbers or 2 odd numbers. I don't think I can do that. I'm not sure. I can't, oh look, I can rule out a 2 from the corner. Is this somehow going to be what we have to do next? I doubt it. Now everything's been really pure to this point. Come on, you have to think, Simon. You have to use your brain. Okay, what I will do then is I will think about row 4, because I can do some parity trickery here. I've got a domino here that must contain an odd number, and that odd number is a 1, because it can't be 3, 5, 7 or 9. So that means that this domino, which must also have one odd number in it, has got a 9 in it. And the 1 here means that's not a 1, which means that there is a 1. Oh, look at this. Come on. Come on. So now that I've got 1 and 3 in here by Sudoku, and that's adding up to 4, and I'm going to have to add an odd number to that, which is not 5 and not 9. So this is 1, 3, 7. I don't believe it. This is beautiful, isn't it? Oh no, but it doesn't fix. Hang on. Now there's a 7 in here by Sudoku, but it could have 6 with it. Okay. 7, it can't have 2 in it, actually. There's no 2 in there. And there's no 8 in. No, it is. This is done. Because there's 7 in here, and it needs an even number, which is not 4. It can't be 2, and it can't be 8. Because 9 and 15 are not prime, so it is 6. So that's 6, that's 7. That might help us. Maybe. So 6 is now living up here, which is not in the 9 cage, because 9 and 6 is 15. That doesn't add up to an... no, well, 15 is not prime. So now... Oh, okay, so now we do have 9 and 6 here, which is odd. We need to retain the parity. So we need to add something like 2 to that, or 8. I think either might work. 17 or 23. Yeah, okay. So I can't do that. This has got to be a 5. It's got to be odd. And it can't be any other number. So that's 5. So these cells are now 2, 4, 8 and 9, I think, to complete this box. 8, oh no, I thought I was going to get the 8. 9, nearly. 2, it's actually, we're whittling away. We are whittling away at this. Although it's now, oh, that's not 7. That's not 6. Okay, maybe a bit of Sudoku is what we have to do now. Let's try that. I know 9 is in here, so I need to accompany that with maybe 4 or 8 or 2. Oh, bother. Over here, what do we need? We need to accompany this with 2. Ah, no, 8 can't go in here. 1 and 8 is not prime again. So this is 1 and 2, and that means that this isn't 2, which means this is 2, which means by Sudoku this is 2, 6, 9, and 2, 6 and 9 do add up to 17, which is prime. So over here we're left with 8 and something, 8 and 5, and 8 and 5 is 13, which is prime. Beautiful. Okay, and now we know the contents of this cage as well, which is 1, 4 and something. Not 2, not 3, not 4, not 5, not 8, 1, 4 and 8. Which is 13, which is prime, unsurprisingly. So those 2 digits are the same. What does that do? That must do something. Oh, bother. 2, is it 2 in that? No. That's not 7. I've just spotted a tiny bit of Sudoku. So 7 is in this one. I think I am going to get rid of the O's actually. Let me get rid of the O. corner mark. I think I would just remember that this is two odd numbers added on to a 7. Again, it could be 1 3, couldn't it? That would give us 11 very easily. 1 9. Yeah, okay, so we still don't know how this works. 5 can't go in this one. Oh, 5 doesn't go there. Look, maybe that's. So we've got quite a lot of odd numbers down this column. There's 4 in that little congregation. Can all of those be even? Maybe. Don't see why not. Okay. Oh, botheration. What am I meant to do now? 5. 3. Oh, look, it's Sudoku. I've got a 3-5 pair here now. Is that good? Has that cleared up something? Oh, all right. Yeah, okay. Where does 7 go in this column? That's very peculiar. But it appears to only have one place it can live, which is there. Okay, that's good. So now these squares. I see 2 comes out of this one. Oh, this is a naked single. This has become a 6. And I get a 1 4 8 triple left. So this square has to be the same as this one. Six comes out of these squares, and I'm left with a 2 9 pair, which doesn't appear to be resolved. And I can't now remember what I thought this digit was, but we can get the parity of this one, can't we? Odd, odd. So we're on even at the moment. We're still on even, so that's odd, which is 1 7 or 9, I want to say. Which, is that good? I don't think that probably is very good. Seven is a little bit restricted it's in one of those squares. Ah, bother. Can almost do magic, look. With these two in terms of parity, I can see, because these 3 cells are odd, obviously, or each of them is odd. So at the moment this cage is on an odd total, so this domino has even parity, which means it's either 2 evens, which would have to be a 4 6 pair. That would make this a 1. Or oh no, that's it. Oh, that's absolutely beautiful. It's really simple. It's really simple. All you have to know is what do the 5 Sudoku odd numbers add up to? They add up to 25. 1 3 5 7 9. So this, although it is absolutely true to say these could by Sudoku be odd, that cage would contain all the odd numbers and would add up to 25, and that's not prime. So this has to contain 2 even numbers, which have to be 4 and 6. Isn't that beautiful? And now that, right, so now this is 9. This is 1. That's going to give me a 4 here and a 6 here. And that digit, that's not 9 anymore. So we're on 3, 5 and 7 for this digit. Now, come on. 4, 6 here. There's a 4 in there apparently, so 4 is in this top domino up here. But it could have 7 with it. Yeah, so just to explain that, obviously asking where 4 goes in row 1 is the simplest way to see that there has to be a 4 in this domino. Oh, we can probably narrow this down, because that totals 18 at the moment. Oh, 19 is prime. So 7 doesn't work, because 25 isn't prime and 27 is not prime. So that, I think this might have to be a 1. 18. Yeah, that has to be a 1. It's the only prime number that works. So that's... well, that gives me 4, 8, 8, 4, 1. Okay, that's now 4. 1, 6. Come on, please. A bit Ah. Oh no. I thought we were on a good track there. I'm still hopeful actually. I'm looking at how much we've done. We've done quite a bit of this. Come on. Oh, we're not going to get any threes in the corner though. That 3 takes care of the last opportunity. Right. What on earth am I meant to do now? It could be... we know that there's a 4 in here. And we know that... So is it something to do with the other odd digits then? This has got to have 2 odd... No, we've got 1, 3, 5. No, the 9 could go up here, couldn't it? 9 and 4 is okay, 7 and 4 is okay. Right, okay, let me think again. Do I know? I must know I do know the parity of this digit, I just keep not writing it in. Alright, let's try. What could we do? What could we do instead? 2 by Sudoku is in one of those 2 cells. I don't think that's going to be... That's not going to be the clever thing we need to do, is it? Wow. Oh, look, 1. I've got more Sudoku I can do in this column. Maybe that's going to help me. So 6 now. Is in one of these squares. But you can't, we can't put 6 in this domino because there's a 4 in this domino. So 6 is now in those squares, and look at that. Okay, so now we can ask where 6 goes in row 1, and it's not in any of those cells, which means that is in the corner, which means now I get a 2-8 pair here. Oh, I thought I was about to break the puzzle because I could see that was putting 2 in one of those, but 2 is fine. Okay. Oh, I don't know. I think... what do I think? Let's... These squares here are from 4, 7 and 8. No, not... Yeah, that's right, isn't it? Not 4. 7, 8... 7, 8 and 9, I should say. 7, 8 and 9. And I know there's a 7 up here. I can't put an even number in that top box. So this... Oh no, hang on. No, there's a 4 in the corner. Sorry, I just didn't see it. I went to all the trouble of noting that the 4s were placing a 4 in the top row and then didn't see that there was 2 4s looking at this. So we get a 4 in the corner. That's 7 or 9, both of which work. 2, 4. So there are 6 and 8 in this cage then, I suppose. Is that correct? I think it is. So 6 and 8 is 14. We can't add 7 to that. So we must add 9 to it and get 23. Beautiful. So this is a 7 in the top position, which means this is not 7. This is 6, 8, 9. I don't believe it. That means that's not 7, I suppose. That's not 7. Maybe that's important. 3, 5. Yeah, that gets me a 7 here. And a 1, 3 pair. Oh, I know one thing we could think about now. We could think about how to make this prime, couldn't we? Because we know that this is odd. Let's actually put in all the options. And we know that by the secret... we've got 45 for the row, minus 19, so that's 26. So the sum of these cells is 26. Well, I can't make this 1 then, because that's going to add up to 25. 3 would work, wouldn't it, I think? 3 would give us 23. 21 doesn't work, so we can take 5 out. So this is being... Oh, I've got a 3-9 pair. Now, can I get rid of 9? Let me just think about that. No. No. 9 will give 17 here, won't it? And that will work, I think. Bobbins. Bobbins McBobbins face. I think that's what we have to say. Okay, but 8 in the top row is now definitely in that cell. And there has to, look at that. Now, there has to be an even digit in this domino or it cannot add up to an odd number. So the 2 goes there. Which, that is doing work. What a remarkable puzzle this is. It is still going. Okay, so now this is odd for sure. And it's not 1. But it could be 3. It could be 5. It can't be 7. That would give us 9 here. And it could be 9 as well. So that's 3, 5 or 9. All of which seem to be possible. And I saw this 3-9 pair here. And, okay, and we know that there's a 7 up here as well. I just don't think this is going to be restricted enough. Although, okay, so I can't have the other of 3 or 9 in the cage, can I? So it's going to be 3 or 9, 7, and 1 or 5. And that's it. You can't put 5. That's as simple as that. You can't put 5 in the cage. It's so clever, but you can't, because if you put 5 in this cage, 5 joins up with 7 and makes 12. And whether we add 3 or 9 to 12, we're going to get 15 or 21, which are not prime. So 5, which can't go with the 4, of course. I think that's been available for ages. That's a 5, that's a 3, that's a 5. Okay, has that done it? This is no longer a 3. This is now exactly equal to 9. So that's 9. That's 3. So we've now got 16 here. And the other digit's got to be a 1 to make 17. So 1 and 7 go in. This has got to be a 3-4 pair. Which means we've got the 1, 2, the 2, the 8, the 8, the 5. Okay, and hopefully we'll be able to unscramble the top of the grid. Maybe. We need this square to be 1 or 9 only. Can't be 3 because of this one. What's this digit? Let's check. That's got to be a 1. Okay, well that's going to make this a 9, which is going to make that 9, that 3, that 3, that 1. Let's double check this adds up to a prime number. We've got 14, 17. That does. That's a 5. That makes this 7, which is fine. 5, 3, 3, 4, 4, 6. 9 here, 8 here, 6 here. 9, 2, 2, 8. 1, 7 and 7 there. What a brilliant puzzle that is. Nil! Oh, my timer didn't start. Why does it do that sometimes? I don't know. 100 people have solved that in 7 days. Well, there are 100 very happy people, I'm guessing. That was fantastic. Absolutely fantastic. It's basically a parity exercise combined with some remarkable choices of sort of numerical division. So whatever it was in that 32 thing that we had to divide in that column between 2 cages, and there was only one way it worked. Things like that were going on. I think there were 2 or 3 bits where I could have got to the logic more quickly. I think there's something going on with these green cages. I couldn't see that smoothly enough. And I think I have a feeling that this being a 5 was available more or earlier. I'm not sure. That was just a sense I got as I was feeling through the solve. But I loved that. That was brilliant. Let me know in the comments how you got on. I enjoy the comments, especially when they're kind. And thank you to Agent for a stellar, stellar puzzle. And we'll be back later with another edition of Cracking the Cryptic.